Right now we will learn all of the chord theorems in a circle. There's 3 of them. They are if and only if statements, meaning they work forwards and backwards. So we are going to do examples for all of them. Here we go. Here's our first one, the congruent corresponding chords theorem. This is an if and only if, so we are going to go over what that means too. Okay, so this is one way we can read the theorem. If the arcs are congruent, so here I have these 2 arcs marked congruent, then that tells us that the chords are congruent. We can read that backwards. And we could say, well, we know that if the chords are congruent, then that means that the arcs are congruent. And this works within one circle or in congruent circles. Congruent circles have the same radius. So that is going to be the same. So our examples here are for congruent circles. It's probably the only time you'll see the congruent circles because I usually work with just inside one circle when I do my examples. So here we go. So here we have a diagram. Not only do we tell you that these guys are congruent, yes, it's marked. So we have congruent radii. They're telling you that you have congruent chords. So in congruent circles, when you know that these 2 chords are congruent, that means that these corresponding arcs are also congruent. This guy here is 120, so arc FG is also 120 degrees. This guy over here on the right, we have congruent circles, they tell us, and they mark it. We have, again, congruent chords because they tell us they're congruent, so as a result, we know that these corresponding intercepted arcs are also going to be congruent. So this guy's 80 degrees, so you know what? Arc FG is also 80 degrees. There are more interesting examples for that theorem, but that's what we have for right now. Okay, the next theorem. Perpendicular chord bisector theorem. This one's another if and only if. Kind of works forwards and backwards, but they didn't kind of write it that way in this example. Okay, so here, if you have this diameter, and by the way, we can have a diameter or a radius. Just make sure you do touch through this center point. If that happens, and it is perpendicular to a chord, then what happens is it's going to cut that chord into 2 congruent pieces, and it's also going to cut that arc into 2 congruent pieces. On the flip side, if you have a segment that is perpendicular to the chord so that it cuts that chord in 2 congruent pieces, well then that means that it's going to be a diameter. Okay, so we'll do examples both ways. Let's check these guys out. Okay, so for this guy down here, number 3, we have, a diameter. So I do see this guy here is a diameter, and I see that it's perpendicular. So I see this chord HK. So as soon as it's perpendicular, I'm going to mark these 2 pieces on the left and right congruent. They're congruent. This one is 14, so this one on the left, hey, you know what? That's 14 also. But notice the question asks for KH. So that's K all the way over to H. So 14 plus 14, that's 28. Moving on. So now not only is that chord cut into 2 equal pieces, hey, so is this arc. So these 2 pieces are the same. So that means that 2x minus 8 is equal to 127 minus x. Add the x to this side, 3x. Add 8 to this side, 135. Divide by 3, and we're going to get 45. That's what x is. They don't ask us for x. So since that's what x is, I'm going to take it and plug it in. When I plug it in over here, 90 minus 8, that's 82. Also on this side, that's 82 degrees. Still not helping me because they want H, L, K. You could take out your calculator and you could take your whole circle of 360 and subtract 82 and 82 again, but I'm going to do it the hard way. So since I know I have a diameter here, this piece on the right is 180 degrees. If this piece is 82, that leaves me with 98 here. Same thing on the other side, so I'm going to go 98 plus 98, and I'm going to get 196 degrees. Moving on to this example on the right. So for this one here, I do see that I have a diameter. Goes through here. Oh, and it's perpendicular to the chord, so I know that chord pieces are congruent. This one is 7, so this one on the left is 7. They want H, K. 7 and 7 is 14 done. The other thing I know is that since it is perpendicular to the chord, it cuts the chord in half, and it's going to cut that arc in half. So I know that this 11x piece on the left is equal to 70 plus x on the right. Minus x to the other side, 10x is equal to 70, divide by 10, and x is equal to 7. So I'm going to plug it in, 77, because I added 11 times 7. Well, that's 77 over there. They want h, k. Well, here's h, here's k, so the arc is going to be only 2 letters. That's the minor arc. That means you're going to add, or you're going to figure out which side is less than 180 degrees, and that's the side. So it's 77 plus 77, hey, that's 100, whoops, and 54 degrees. HK is 154. All right, let's move on to the next few. Okay, so these guys right here, the equidistant chords theorem. Okay, this guy also is an if and only if, and we are going to kind of go back and forth a little bit, and this is what it says. So sometimes it's easier for me to read these pieces. So this one says that we have congruent chords. So if AB is congruent to CD, then you know that they are both equidistant from the center. So EF is going to be the same as EG. The other thing to know is that we're using the word distance, equidistant. Distance is measured perpendicularly. Remember that word? We made it up because it works. So distance is measured perpendicularly, so that implies that you have right angles here and here also. Let's do this backwards. So we're going to start over here. So if we have these two segments here equal, so if EF and EG are both equidistant to a chord, so they are equal, and because we're talking distance, we know perpendicular, then those chords are equal to each other. Okay, so let's move on and take a look at these 3 examples that we have here, because they're kind of good. All right, so here's this guy on the left. So we know that these pieces, 12 and 12, these guys are the same. So now I know that these 2 chords are going to be the same. They don't give me the whole entire chord. Instead, what they tell me is this little piece. Well, maybe they do give me the whole thing. But either way, the other thing I remember from my last class, here it is. Okay, so now if I am through the center, and if it's perpendicular, then it cuts that chord in half. That's going to be used in just about all of these problems. From the center, perpendicular, cuts it in half. So these pieces are congruent. These pieces are congruent. So now I got all 4 of these guys the same. Let's write a little equation here. So I know that 7x minus 3 is 5x plus 7 minus 5x, add 3, and x is equal to 5. Fine. What did they want us to find? Oh, not even x. Find the radius of E. Okay, so I'm going to take 5 and I'm going to plug it in. So when I plug 5 in, that's 25, and 7 is 32. You know what? I think they did want it to be the whole entire chord when I look at 32. So that's the whole entire thing. And on this side also, 32 is the whole entire thing. They want us to find the radius. Here's something that I want us to remember. If this whole chord is 32, remember we said these pieces are congruent. This guy here is 16 and this guy over here is 16. We don't even have a radius drawn in this picture, and this is a very typical problem for chords. Chord problems are all about right triangles, and this is where you're going to find your right triangle. A radius goes from the center and it goes to any point on the circle, and the point that's going to work the best is going to be the end of one of your chords. It can go this way, it can go up to C, to B, or to A, but any way you draw it, make sure that you close off one of these triangles, and it's a right triangle. Remember, this side here is 12, so that's your A squared. This side, 16 squared, so side squared plus side squared is equal to your hypotenuse, which I put an R there, if you can't tell, is equal to my radius squared. Pick up the calculator, do 12 squared plus 16 squared, that happens to be 400. Take the square root of both sides, and your radius is 20. It's a triple, by the way, for anybody who's way ahead of me. There we go, number 6. In this diagram, okay, so now I have this chord and this chord. Not only are they congruent, but they're both equal to 24. So since it's 24, look at this, from the center, perpendicular, cuts it in half. That's 12 and that's 12. Here's for V, it's 12 on this side, 12 on that side. I'm not going to write it in. So now, not only do I know what those little pieces are, I know that because the chords are congruent, they are equidistant. So these pieces are equal to each other. So 5x minus 9 is equal to 2x. Negative 9 is equal to negative 3x, and x is equal to 3. Let's plug it in, and that's going to give me 6. Find the radius. Oh, what is here? QU. QU is 12, and CU is 6. Well, look, find the radius. Maybe since they mentioned those two, maybe I'll make my triangle here. But look, finding a radius means that I have to come from the center to one of these endpoints of the chord because I have to make a right triangle. Here I have a right triangle. I have 6, 12, and R for radius. So 6 squared plus 12 squared is equal to R squared. So I pick up a calculator, and I'm going to do 6 squared plus 12 squared, and that's 180 is equal to R squared. If you want to, at this point, you can take the square root and get whatever the decimal is, but I think that that's 36 times 5. Yep, 180. So square root of 36, that's 6. Radical 5 is equal to R. So that's what my radius is. Last guy, let's see how quickly I can do this. So these two segments are not only equal to each other, they are 80. So this one is 40, and that's 40 also. And since they're equal to each other, they are equidistant from the center. So 7x minus 12 is equal to 3x. Negative 12 is equal to minus 7x to the other side. Divide by negative 4. X is 3, so this side is 9. We want to find SR, which is a diameter. Remember, a diameter is 2 radiuses together. 2 radii. So what we have to do is find one radii, and I'm going to use NJ. It doesn't matter where, but I'm going to use this one right here. And this is, it's a triple for anybody who remembers, but that's 9 squared plus 40 squared is equal to your R squared. You go ahead and do this, and it's going to be 41 is equal to R. So since your radius is 41, this piece is 41. This piece is 41. SR is 80